What happens when an AI agent does not just answer a question, but actually takes action? It reads your database, it calls your API, it writes files, it triggers background jobs, it sends messages, it maybe even touches production infrastructure. Now ask yourself something uncomfortable. If that agent makes a mistake, do you want the system around it to be loose, dynamic, and easy to accidentally break? Or do you want every tool call, every state transition, every permission boundary, and every failure path to be explicit? That is where Rust becomes interesting. Most AI agent demos today are written in Python or TypeScript. And that makes sense. Python is fast for experimentation. TypeScript is great for web products. If you want to build a prototype agent in one afternoon, you probably should not start with Rust. But production AI agents are not just prompts. They are distributed systems. They need queues. They need memory. They need tool execution. They need retries. They need streaming. They need permission control. They need observability. They need to fail safely when the model returns something weird. And this is the part people miss. The harder AI agents become to operate, the more they start looking like backend infrastructure. So the real question is not, can Rust replace Python for AI agents? The real question is, when AI agents move from demos to production systems, does Rust become one of the best languages for the infrastructure layer underneath them? In this video, I want to break this down honestly. We will look at what AI agents actually need, where Python and TypeScript are still better, where Rust becomes powerful, and what the Rust agent ecosystem looks like in 2026 with tools like Rig, Tokio, Axum, Serde, vector databases, and local inference frameworks like Candle. Let's get into it. Before we dive in, I want to talk about Aarambh Dev Hub's partner, CodeCrafters, and this one I actually mean it when I say it is a good one. If you have been watching Aarambh Dev Hub for a while, you already know that we are all about understanding how things actually work under the hood. Not just using tools, but truly understanding them. Why does Redis work the way it does? How does Git actually store your commits? What is really happening when you type a command in your shell? CodeCrafters is built around exactly that same curiosity. CodeCrafters is a platform where you rebuild real developer tools from scratch. Things like Git, Redis, a shell, an HTTP server, a DNS server, a BitTorrent client, you actually build them yourself, stage by stage, in your own language. Every stage unlocks the next, and you can see exactly how far along you are as you go. Now the most popular language on CodeCrafters is Rust, and that makes total sense for this channel. If you're just getting started with Rust and want to learn it the right way, this is honestly one of the best approaches out there. Instead of reading theory or doing small exercises that go nowhere, you sit down and build something real. Something you have actually heard of. Something that exists in the real world. And that is when Rust really starts to click. This is not your typical tutorial platform where you just watch someone else code and feel like you learned something. You are the one writing the code. You are the one debugging it. You are the one making it pass each stage. That kind of active, hands-on learning is what actually makes you a better systems programmer, and I will be honest. It is genuinely a lot of fun. The challenges are used by engineers at companies like Google, Meta, and Shopify. And if your company has a learning and development budget, there is a very good chance CodeCrafters is covered under it, meaning it could cost you absolutely nothing out of pocket. Worth checking with your manager before you pay yourself. The link is in the description below. Check it out, and if you do sign up through it, you also directly support Aarambh Dev Hub, so thank you in advance if you do. Alright, now let us get into the video. The first mistake people make is thinking an AI agent is just a better chatbot. A chatbot receives text and returns text. An agent receives a goal, reasons about that goal, chooses tools, executes actions, observes the result, and continues until it reaches an answer or fails. That sounds simple until you put it in production. Because now the model can ask to call a function. That function might hit your database. The database might time out. The tool result might be too large. The model might call the wrong tool. A user might ask something malicious. A background job might execute twice. A memory entry might be stale. The model might hallucinate an argument that your API does not accept. This is no longer just prompt engineering. This is systems engineering. A serious agent runtime needs 5 things. It needs a tool layer, where every external action is defined clearly. It needs memory, because the agent needs context beyond one message. It needs orchestration, because one task may require multiple steps. It needs safety boundaries, because not every model request should be allowed to execute. And it needs observability, because when an agent fails, you need to know exactly which step failed and why. This is why the programming language starts to matter. In a demo, flexibility is more important than correctness. In production, correctness becomes the product. Before anyone gets angry, let me say this clearly. Python is still the best language for AI experimentation. The LLM ecosystem is built around Python. Most model examples are Python. Most research code is Python. Most vector database examples are Python. Most teams doing quick agent experiments reach for Python because it gets out of the way, and that is a real strength. If your goal is to test whether an agent workflow even makes sense, Python is probably the correct choice. But the same thing that makes Python beautiful for experimentation can become painful in production. Dynamic types are fast when you are exploring. But when the model produces a JSON payload with a missing field, wrong type, or unexpected nested structure, you want the compiler to force you to handle that. Runtime errors are acceptable in a notebook. They are not acceptable when an agent is calling payment APIs or modifying a user's data. Python packages are flexible, but production deployment can become heavy. Virtual environments, dependency versions, native wheels, container size, cold start time, and runtime memory overhead. Again, this does not make Python bad. It means Python is strongest at the top of the AI stack: research, prompting, experimentation, and notebooks. The agent infrastructure layer has different requirements. Rust has 3 advantages that map directly to production AI agents. The first is type safety. Agent systems deal with messy inputs. User messages are messy. Model outputs are messy. Tool results are messy. In Rust, you can model that mess explicitly with enums, structs, results, options, and Serde validation. Instead of assuming that the model returned the right shape, you parse it into a real type. If it fails, the failure is part of your program flow. That sounds boring, but boring is exactly what you want when a model is controlling tools. The second advantage is concurrency. Agent systems are naturally asynchronous. You call an LLM provider. You call an embedding API. You query a vector database. You call an internal service. You stream tokens to the front end. You run background jobs. You retry failed calls. Rust's async ecosystem, especially Tokio, is already built for this. Axum gives you a modern HTTP server. Request gives you HTTP clients. Serde handles JSON. Tracing gives structured logs. SQLX gives compile time check database access. This is not a toy stack. This is serious backend infrastructure. The third advantage is deployment. A Rust agent service can compile into a single binary. You can put it in a small container. You can run it at the edge. You can keep memory usage low. You can start quickly. You can avoid shipping an entire Python runtime for the service that only orchestrates tools and inference calls. This does not mean every agent should be written in Rust. It means that when an agent becomes a backend service, Rust starts making more and more sense. Now let's look at the actual ecosystem. Because a few years ago, saying Rust for AI agents sounded like theory, in 2026, it is more realistic. The most important framework to know is Rig. Rig is a Rust library for building modular LLM-powered applications. It gives you abstractions for completion, embeddings, agents, and integrations with model providers and vector stores. The important idea is that Rig is not trying to turn Rust into Python. It is trying to make LLM workflows feel native in Rust. That matters because Rust developers do not want magic hidden everywhere. They want explicit types and predictable behavior. For lower-level building blocks, you also have async OpenAI for OpenAI-style APIs, Request for direct HTTP calls, Serde JSON for structured model output, schemas for JSON schema generation, and validator-style crates for input validation. For the service layer, Axum is one of the cleanest choices. You can expose an agent endpoint, stream output to the front end, attach tracing spans to every request, and run it with Tokio. For memory, you can use Postgres with pgvector, Quadrant, LanceDB, or another vector store. The exact database matters less than the architecture. Embeddings go into memory, the agent retrieves relevant context, and the model makes decisions using that context. For local inference, Candle from Hugging Face is worth watching. It is not the same as a full Python research stack, but for lightweight inference and model deployment in Rust services, it fits the production story. Let me show the architecture I would use for a serious Rust agent service. The API layer receives the user request. The planner decides what the next step should be. The tool registry defines exactly which tools exist. The executor calls those tools. The memory layer stores useful context. The observer logs every step. And the safety layer checks whether the requested action is allowed. In simple terms, the model can think, but Rust controls what it is allowed to do. That distinction is extremely important. You should never let the model directly execute arbitrary code. You let the model request a tool call, then your Rust program validates the tool name, validates the arguments, checks permissions, executes the tool, and returns the result. Here is the kind of shape you want in Rust. This is the Rust advantage in one small example. The model cannot invent a random tool name unless you allow it. The model cannot send a priority called super urgent unless your enum accepts it. The model cannot accidentally pass a number where you expect a string without the parser failing. And when it fails, failure is not a surprise. It is a result. You handle it. In Python, you can absolutely build the same validation with Pydantic, but in Rust, this style is the default way of building software. Now let me be honest about the limitations. If you are still exploring the agent idea, Rust may slow you down. You will write more types. You will think more about error handling. You will fight the compiler sometimes. You will spend time designing the system before the prototype feels alive. For a hackathon, Python is probably better. For a product demo, TypeScript may be better. For a research workflow, Python is definitely better. Rust also does not have the same amount of AI agent tutorial content. Python has LangChain, LlamaIndex, DSPy, CrewAI, and a huge ecosystem of examples. Rust has promising libraries, but the ecosystem is younger, so if your team is mostly AI researchers, moving everything to Rust would be a mistake. The better pattern is hybrid. Use Python for research and experimentation. Use Rust for the stable service layer, APIs, tool execution, queue workers, data pipelines, inference wrappers, and permission-sensitive workflows. That is where Rust shines. If this breakdown is helping you understand the real role of Rust in AI infrastructure, hit the like button. It helps this video reach more developers who are trying to move from AI demos to production systems. Subscribe if you want more Rust backend, AI, and systems programming content every week. Let's continue. For Rust developers, AI agents create a huge opportunity. Not because every prompt engineer will suddenly learn Rust. That is not going to happen. The opportunity is that the AI world is discovering backend problems that Rust developers already care about. Reliability, concurrency, memory efficiency, safe APIs, observability, deployment, low latency services, edge execution, secure tool boundaries. That is Rust territory. Think about an AI coding agent. It needs to read a repository, understand files, run tests, apply patches, maybe open a pull request. That is a dangerous workflow if the infrastructure around it is weak. Think about a customer support agent. It may read user billing data, create refunds, update tickets, or send emails. You need permission boundaries. Think about a DevOps agent. It might inspect logs, restart services, or run commands. You need safety. Think about an enterprise knowledge agent. It retrieves internal documents and answers questions. You need access control, audit logs, and data isolation. The model is only one part of the system. The infrastructure around the model is where Rust can win. So, is Rust the future of AI infrastructure? My honest answer is this: Rust will not be the main language for AI research, prompt experimentation, or model training. Python keeps that crown, but Rust has a very strong chance to become one of the main languages for production AI infrastructure. Not because it is trendy, because the requirements match. AI agents need safe tool execution. Rust gives explicit types and controlled side effects. Agents need concurrency. Rust has Tokio and a serious async backend ecosystem. Agents need small, efficient services. Rust gives single binaries and low memory usage. Agents need reliability. Rust forces error handling into the design. The winning stack may look like this: Python for notebooks, training, and experiments. Rust for agent runtimes, tool servers, API gateways, queues, memory services, edge inference, and high-performance data processing. TypeScript for the front-end and product layer. That is not one language replacing another. That is each language moving into the layer where it is strongest. And for Rust developers, that is very good news. So that is the full picture of Rust for AI agents in 2026. The question is not whether Rust replaces Python. The question is whether production AI agents need a safer, faster, more reliable infrastructure layer underneath them. And my answer is yes. When an AI agent is just a demo, Python is enough. When it starts calling real tools, touching real data, and running inside real products, Rust becomes extremely interesting. If this video gave you clarity, hit the like button. Subscribe for more Rust, backend, AI infrastructure, and systems programming videos. Drop a comment: would you build an AI agent runtime in Rust, or would you still choose Python or TypeScript? Join the Discord community from the description if you want to discuss Rust projects with other developers. And if you want to support the channel, Buy Me a Coffee and GitHub sponsors links are below. Thanks for watching and happy coding.